All right, everybody. What are line graphs used for? Will? To plot answers. Okay, let's get a little further than that. To plot what kind of answers not say? To plot measurement. To plot good information. Yep, to plot measurement. Let's think about our ice cream experiment with milk. What were we looking for? What do we want to see with our experiment? Temperature. Temperature what? Temperature, so dropping. So difference in temperature. What does that mean? What word? Start with a C.
Celsius.
Okay, that was our units. Decrease is what we were looking for. But what is it when something is different? Change. Thank you, Miss Matthews. We were looking for a change. We were looking for a change in our temperature. So a change in temperature or a change in anything is called a trend. When it's measured over time, it's called a trend.
I thought a trend was like a fashion thing.
Okay, it is just like fashion. Thank you, Billy. So the fashion for wearing hoodies. Someone said hoodies yesterday. A few decades ago, so like 40 or 50 years ago, hoodies were in. And then all of a sudden, in the 80s, right? Nobody wore hoodies.
What?
Nobody wore hoodies in the 80s and 90s. And in about 95 or so, everybody started wearing hoodies again. So just like you said, Billy, a trend is a change. So that desire to wear a hoodie kind of went in and went out and went in again. Okay? So good job. Everybody's answer should be line graphs are used to show trends. When you graph something and you connect the dots, T-R-E-N-D. When you connect those dots, it's easy for your eyes to see a change or a pattern in the data, a trend.
That's easy. T-R-E-N-D.
Got it. A trend. If you answer all 5 questions and work through each question with me and each other, you will be definitely able to answer the question on your sheet. You guys got it? Jaquan, you got it?
Got it.
Don't read that question yet. Don't worry about it yet. We're working on the first 5. Okay, so while I read the question, please do not talk. What happened shortly after you added the salt to the ice cubes? Was the temperature above or below the freezing temperature of water? 1. What's the freezing temperature of water in Celsius? 0. Okay? 0. So look on your data table at step 1 and step 4. Step 1, we measured the temperature of only ice. Billy. Step 4, what did we add to the ice?
Salt.
Salt. Now look at the temperature that you wrote down for step 1 and step 4. Which one was higher?
Guys, look at your data.
Raise your hand if step 1 was a higher temperature than step 4. So the temperature from 1 to 4 decreased. It should have decreased in all of your guys' data.
Listen, guys, you might want to put this down
Billy,
somewhere.
did the temperature from step 1 to 4 decrease?
What number
Yes.
are we on?
Do you have that written down? Just 1. Put that away, bud.
Wait, what number are we on? Just one?
Remember what I said, we need to work on this at the end, so make sure you're working hard on these. Did you guys write down that step in question number 1, your answer should be the temperature decreased. The ice water that was forming is actually super, super cold.
Oh.
Question number 2 says, what is the only factor that could have caused the changes shown in question 1? What did we add to the ice? Salt. So what is the only factor that could have decreased the temperature of that ice water? The salt. Very good. Salt. Do you all have salt written down for step number 2? Question number 2. Okay, let's move on to question number 3. You guys are doing great. Yes, Will. You want to read the question? You want me to?
I want to read.
Go ahead.
For number 3, it says, heat energy is needed to change phase from a solid to a liquid. List the possible sources of the heat needed for this phase change in your basket. Which source do you think is the best possibility and why?
Okay, let's first start off by saying that heat is a form of energy. The more energy matter has, the more likely it is to turn into what? Liquid Or if it has tons and tons of energy, what's it going to turn into? Gas. And more energy, what's it going to turn into? Starts with a P.
Salt. Come on, guys, think.
Starts with a P.
Brother.
Lightning. What's lightning? Starts with a P. L-A. Yes! Yes, Farrah. Plasma.
Fancy TVs.
Plasma.
Plasma TV.
Awesome. So
Plasmas
plasma
blow
has
up.
tons and tons and tons of energy. Right?
No.
Lightning. You don't want to get struck by lightning. Way too much energy for your body to handle. Okay? So the more energy something has, the more it's going to change into a liquid, a gas, or a plasma. Okay, Will, give me one source of heat energy versus question number 3.
Question number 3, hands.
Your hands. What's in your hand that you don't want it to add to the ice cream mixture? Heat. Your hands are full of energy, boys. What else do we have? Dante, what did I tell you to squeeze out of the bag?
Air.
Thank you. You're not Dante. Air. Hot hands and air. Give me another one since he stole your thunder. Give me another source of heat. Whoa. Was the temperature of the milk hotter than the temperature of the ice?
Was it?
I'm at, yeah.
Yes. So, is the liquid milk a source of heat energy?
Yeah.
Yes, because we just talked about how liquid has more energy in it than a solid, right? Very good. So we have milk, we have hot hands, we have air.
There's another one.
What is it, Will?
Salt.
The salt. Very awesome. Let's move on to number 4. In looking at the temperature changes shown on your data table, explain how the energy flow of the baggie system resulted in your tasty treat for an end product. Basically, that question is asking you to look at the temperature difference from the milk, not the salt, the milk throughout the experiment. So take a look at your data table. What happened to the milk temperature throughout the experiment? Trevin. It got colder. Does everyone have that their temperature of the milk got colder? Yes. So what does that mean, Will? The milk lost energy. You guys understand that? The milk lost heat energy, and we can tell because the temperature went from what to what? High to low. Very good. The temperature decreased, meaning that energy was transferred. Where did the energy go? Also got transferred into that. What's that mixture that we were shaking everything inside of?
Ice.
Ice. That mixture. That stuff was melting, wasn't it? Not only because of the salt, also because of heat energy being transferred into that mixture. Okay? Let's go into question number 5. Anybody know anything about cars?
Yes.
Very cool. Okay, then you guys are going to help me out on this one. In the radiator of your car, you put a combination of antifreeze. Anti. What's anti? Against. Not, right? Freeze. Solid.
It makes your car.
Explain how you think this works in terms of what you saw in the experiment you just did. So, basically, the question wants you to relate the adding of salt to water to the addition of antifreeze in your car. Do you guys understand that?
Yeah.
Okay, so first of all, we know from question number 1 that adding the salt to the water, to the ice, made it harder for the ice to freeze. Made it harder for that water to freeze. The amount of salt in the ocean makes it harder for the ocean to freeze. The more salt there is in that solution, the harder it is for that solution to freeze. So, what does the addition of antifreeze do in your car? Go ahead, Nick. Let's hear.
It keeps it cool, and without that, your car would overheat.
Yeah.
Let me say it one more time. Adding the salt to the water. Adding the salt to the water ice made it harder for the water to freeze. Adding antifreeze to the water in your car makes it harder for the water to freeze. It makes it harder for the water to boil. And thank you for working hard today.
You're welcome.